Hello everybody. Well, I thought I would do another video in quick succession of that motion one, which is the second one on projectile motion. But I thought I'd do this one as I did promise some flatty, and I can't remember who it was, that I would cover this in a video. So I'm going to do this helicopter experiment, okay? Now, the reason for doing this experiment is I've noticed on Ranty's channel, every now and then he comes across with some proof that the Earth is flat, because he has some explanation for why you can only see half a boat, or why you can only see half a windmill, or sometimes just the blade. Okay, so they will jump over any amount of hoops, especially this guy called Brian's Logic will jump over any kind of hoop to try and explain how this thing, how you only get to see half a boat. And of course there's this fellow who yells at everybody from his shed, Dell. He is the same. He has this same philosophy that there's some optical reason why you can't see it. You can only see half a boat, and then just the mast, and then nothing. So my challenge is to those people to consider this helicopter experiment. Okay, look at this with a critical mind, okay, and a critical eye, and then stop lying to yourself. Alright, so I'm going to pan across to the board and we'll discuss this helicopter experiment and what it's all about. Alright, here goes. Okay, so as you can see, what we've got here is our little helicopter right over there. Okay, and what's happening is it's getting towards dusk, sunset. So there's the sun, and the sun is about to set. So we're on the ground over here. So hence zero meaning elevation. Okay, so we're on the ground. So between here and here, we're on the ground. So we're watching the sun go over the horizon. Okay. However you think that this happens, flat Earth people, you cannot deny that this is what it looks like. Okay, this is exactly what it looks like. First you see the sun, then the sun gradually goes further and further down. You see only half the sun, then you just see the top of it, and then you see none of it. The sun's gone and it's dark. Okay, so however you think this sun is or happens, you cannot deny that this happens. Okay, well, the next thing you do is you climb in the helicopter and you climb up to 1,000 feet. And you look across and you can see that the sun is back again. Same angular size, that hasn't changed. Same angular size as before. And the sun is back again, off the top of the horizon. Well, you hover around 1,000 feet over here. Okay, you wait and you'll see the sun will go halfway, half a sun. It'll keep going down, then there'll be none. It'll be dark. Okay, you can't deny, flat Earth people, that this is what you see. So next, what are you going to do? You get in your helicopter and you go up to 2,000 feet. And lo and behold, there it is again. That pesky old sun staring at you again with the same angular size. Nothing's changed. Where did it come from? Because surely it would be gone a long way by now. But it hasn't. It's just over the horizon. Just wait for it and it will go again just like it did over here. And then it'll get dark. And you want to see it again? Just go up another 1,000 feet. It's not that hard. Okay, so this is what happens with the helicopter. Now you've got to ask yourself some serious questions if you want to be taken seriously. How is this happening? Why is it you can go up and see the sun again? All right, let's have a look. Okay, let's accept that you've got the flat earth this time. All right, so we're saying the flat earth. What would we see if it was flat? This is what we actually see. This is the explanation for it. Go up 1,000, you see more, and so on. Okay, what would we see if it was flat? Well, there's our sun. Let's assume that we would see it close to the horizon like that. I doubt it, but I'm going to give you that. We see the sun near the horizon like that. Well, after a while, the sun just gets smaller. It's still over the horizon. And then you look again, you know, after some time, roughly about the same amount of time, so if that's our time interval, look again, and it's smaller again. And it keeps getting smaller, smaller, and smaller and smaller. And not only is it going smaller, but remember, the sun is going around in a circle, right? That's what you say. That's those of you who admit that you have a model. The others will just say, I don't know. I'll come back to this I don't know business. So here we go. What's going to happen is the sun, not only is the sun going to just get smaller and smaller, but it's actually going to change direction. So it'll be further and further away, you know, towards your right. Okay, if it's going to go around like this. Okay, all right. So it's going around, assuming that it's going. Well, it depends if it's going in a right-handed circle, or is it going in a left-handed circle? Which way? Whether it'll go this way or that way? Well, you figure that out, because it does neither of those. It does not do this. Okay, and by the way, another point. There would be no place, there would be no stage at which you would not ever see the sun at all. Okay, it's not going to come below this point, because it cannot. It cannot come below this point, below this line. So it's going to always be above this. This will just be a hazy area over here, because you can't see any further. There's be no abrupt horizon as I've drawn it like this. This is really a concession that you would not have, okay, if you're talking about like that. But you most certainly would see the sun reduce in angular size like this to where it's a point. Now, it would never go away. It would always be at least a point of light. You'd be able to say, well, you know that little shiny thing out there? That's the sun. Everybody would know what it was. Just like the reality is, we do look at stars and we know that they're suns. They're just not our sun. Okay, all right. So this is what it would look like if it was flat. This is what it looks like, the reality of what it looks like, and this is what it happens from the helicopter. Now, if you care that what you believe in is true and factual, forget true, just factual. If you care what you believe in is factual, then you will ask yourself these questions about this. Okay, Brian, are you listening? I've got a video coming up shortly, which will go through those that experiment that you did with the jars. I had my own jars. Brian, what did you think? No one else could do your little jars on the table experiment? Well, I'll show you what it looks like when you put jars on a flat table. They don't disappear bottom up. They just get smaller and smaller, Brian. Wait for my video. I'll show you. Okay? All right, so this here is a serious question that you need to ask yourself about this helicopter. How does this happen? This is what we see. This is what happens if you do go up. You see more and more of it. This is what you would see if it was flat. We don't see this. Logically, this does not happen. So therefore, the Earth is not flat. Okay, if you like my videos, please press the subscribe button and also the like button and that bell, and then you'll be able to be notified of the next one coming along. So I'm going to tackle Brian, and then we've got to get on to more motion, which is the circular motion. So then we'll have a proper look at gravity and proper look at orbital mechanics and how gravity helps us understand what's happening in our world. We'll also have a look at the universal gravitation equation in some detail, so that you can understand how that came about and why it is we accept it. Why do we think that it's right? Okay, I'll even throw in a bit of the intersection between Einstein and Newton and show you how they complement each other. Okay, so in other words, there's nothing about Newton that overtakes anything Einstein says, or vice versa, or what Einstein says that disputes Newton. The only thing that Newton did say was that he didn't want to ascribe himself to ascribe an explanation for what gravity was, but he sure damn well knew how it worked. He got that right. The fact that things are attracted, mass is attracted to mass, he got that right. Newton didn't know why. He didn't know the mechanism. Einstein worked that out. But the fact is, that didn't change the fact that mass does attract mass, as Cavendish so eloquently showed us. Okay, all right, so see you next time.